Today let us discuss about Dijkstra algorithm. Dijkstra algorithm is a single source algorithm, which means that we are given a source and we should find shortest path to all the other vertices in a given graph. So here consider A as a source, so we will find shortest path to all the other given vertices in this graph. It is a greedy method, which means that we first try to find the shortest path to its neighbors. So here it might be C, B or D, and then we continue to find to all the other vertices until we cover all the given vertices in the graph. It is a breadth first search algorithm, which means that we are searching through the breadth completely and we continue until we reach all the other vertices. So what is the drawback of Dijkstra? So Dijkstra graphs cannot have negative weights. So for example, if we are going from U to V and if the cost is -6, so those kind of graphs doesn't work. But those kind of graphs do exist, and in a business application, if you try to go from a state A to state B and you might incur a loss of $1,000, so you could represent it using -$1,000 as a cost. But those kind of graphs are not useful when we are trying to find shortest path using Dijkstra. So here in Dijkstra we use a concept called relaxation. So what is relaxation? Relaxation means, consider you are going from New York to Los Angeles, LA, and we don't know initially what is the distance between New York and LA. So then suppose that we also don't have an access to Google Maps, so we are going by just following the road signs. So I'm at New York U and I'm trying to go to Los Angeles V. So by following road signs I have reached Los Angeles and I have found from my car meter that it's 600 miles. And one of my friends suddenly suggested, hey, why can't you use Google Maps? So then I learned about Google Maps and I tried to search what is the distance between New York and Los Angeles. I could find that it is 500 miles. So when I go for the next time, I would use that path instead of my longer path. So I have relaxed it from 600 miles to 500 miles. So this is what is called relaxation. Whenever we find the shortest better path, we will relax it from the previous founded value. So this is what we use in finding shortest path in Dijkstra algorithm. So consider this graph. So we have many vertices here and consider our source is A. So first we will create a table, and this table cannot have the row values. So initially all the columns are filled with vertices. So here my vertices are A through H, so I'm filling from A through H. So my source is A, so I'm writing here A. So I'm trying to fill these boxes now. So please pay attention. So when I'm trying to fill this box, I will consider the neighbors of A. So my neighbors of A are C, B and D. So what are the distances to C via A? It's 2. So I will write 2 slash I'm going via A. What is distance to B? It's 8 and I'm going via A. What is distance to A? It's 0 and I'm going via A. So what is distance to D? It's 5 and I'm going via A. So 5 slash A. And what is distance to E? So as of now A doesn't know about E, so we put it as infinite. And similarly for F, for G and for H we put it as infinite. So we select the shortest path from here and it is C. It's not A because it's already selected here. So we select C here, so we put C in this row. So now we try to relax previous values and find and also consider finding values to other neighbors which A couldn't find. So we don't need this A column because we already found it is the shortest one. So consider B column. So C has neighbors as D and E. It also has A. So we already found it for A, so we don't need to consider A. C has no direct link to B, so it continues to be 8 and it is via A, so we don't change that value. And going from C to C is again 0, and C has a weight of 2 from previous, so 2 plus 0 is 2, and we are going via A, so we don't change that. And for C to D, C has a weight of 2 from previous value, so this is a previous value, it has 2 as weight, and now 2 plus 2 is 4, so going to D via C is 4 and it is via C, but the previous value was 5, so which was higher than 4. So now we try to relax it, we use the relaxation concept and we relax it, and we are going to D via C with a cost of 4, 2 and 2. And now consider E. C has no direct link to E, so we continue. C has direct link with E, so it has a weight of, C has a weight of 2, and the link between C and E is 5, so 5 plus 2 is 7, and we are going via C. So now we could go from infinity to 7 because A's neighbor C has a direct link with E, and remaining values are not defined because C don't have access to those neighbors. Now try to select the shortest among these. The shortest among these would be 4 slash C, and it is D. It can't be 2 slash A because if we select 2 slash A, it is C, and C is already selected. So now we try to select D. So D, and A is already selected and C is already selected, so we don't fill them up. So from D to B, let us see what happens. So D has a direct link to B, and D has a path of 4. So from A to D it takes 4 as cost, and D to B it is 4 plus 2 6, and the previous value is 8, so it is better. The 6 is shorter than 8, so we choose 6 and we go via D. And consider for D to C, C is already selected here, we don't need to fill that up, and D to D it is already selected, so it is 4 and we are going via C. And from D to E, so D has a direct link with E, so D has a previous weight of 4 and 4 plus 1 is 5, so when we go via D the weight of E is 5 and previous value was 7, so now we relax it and we are going via D. So D also has direct link to F, and D has previous weight of 4, so 4 plus 6 is 10 and we are going via D, so 10 slash D. And D also has link to G, and D's weight was 4 and 4 plus 3 is 7, and we are going via D, so 7 slash D. And D has no direct access to H, so that's not determined. Now we try to select the shortest among these, so it is E and not D because again D is already selected, so select E. As neighbors as D, C and G. So first it doesn't have any link with B, so we continue to write from the previous row, and E has link to C, but C is already selected previously, so we don't consider that as of now. And E has link to D, which is also selected, so we don't consider it as of now. And E has link to G, so E has a previous weight of 5 and 5 plus 1 is 6, so going to G costs 6 via E, but previous was 5, so we continue having 5 here, we don't relax it. So E to F, it doesn't have any direct link, so we can't relax it, so we write the previous value. And E to G, which was E has a weight of 5 and 5 plus 1 is 6, so G is 6 via E and 7 previously, so we relax it, it is 6 via E. So now select the smallest one among these. So here we cannot select E because it's already selected, so we could choose any one when there is a tie. So let me select B here. So it's B. So A is already done, B we are doing it right now, and C is already done, D is already done. So let's go to E. So B, from B we can, it doesn't have direct access to E, so we continue to write the previous value, but again E is already selected, so we don't have any need to write it. B to F, it's 13 and B's weight is 6, so it's 19, and previous is 10, which is better, so we write it from previous row. And for G, so B to G has no direct access here, so we continue to write the previous value 6/E. And now let us select minimum among these, which is G. So G has direct access to D and E, which are already previously selected. So let's look at F and H. So G has a weight of 6 and G to F costs 2. So 6 plus 2 is 8 and previous value is 10. So we change it and it's 8. We are going via G. So now we relax it. And G has already weight of 6, which we selected now. So we don't need to write that. And G to H, G has a weight of 6 from previous row, and 6 plus 6 is 12. So now we could relax it from undefined. So it's 12 via G. So these are undefined values. And now these two is F. So we select F here. And let us see if we could relax H or not. So it remains the same for the F column, so it's 8/G, and F has a weight of 8. So let us see. So F has a weight of 8 and 8 plus 3 is 11 to go to H. Previous value is 12. So we relax it to 11 and we are going via H. So now we have covered all the vertices here. So we are done with Dijkstra. So now let us uh, see how we could find shortest path to any given vertex from a source A. So we randomly select F in this case. So for finding shortest path from A to F, we use this table and we could easily find. So let us see the F column first. The F column says that it has a least cost of 8 and we are going via G. So we first, our source is F, our destination is F, and we are going via G. So we write G here, and next we choose the Gth column and select the shortest among these values. So 6 is the shortest and we are going via E. So E is the previous vertex, and now let us see the previous vertex for E. So E column has 5 as least cost and it is coming from D. So put D here, and here choose the Dth column and look through that column for minimum value. It is 4 and we are coming via C. So write C here, and next look through the Cth column and its minimum is 2 and it's coming via A. So that's it. A, C, D, E, G, F is the shortest path from A to F.